The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome, ladies and gentlemen. I'm DrAvitech, and in this video, we're going to be solving this very problem. So we're asked to find the Fourier series of periodicity 3 in the nth term for that very function. So what I'm going to do is to get started with the first coefficient. So the first coefficient is a0. So a0 is 1 over L, integral from minus L to L of f of x dx. So that's a0. And if you notice, L is half the period. Now, since the period is 3, that means L is 3 over 2. That means L is 3 over 2. So this will be equal to 1 over 3 over 2, integral from, our interval is 0 to x. So 0 to 3. So this will be 0 to 3. Then f of x is 2x minus s squared dx. That's what we have. Now, if you take the reciprocal of this, 3 over 2 will then become 2 over 3. So you flip the fraction. So that's 2 over 3. That's what it becomes. Then, if you integrate 2x, first of all, keep the 2. If you integrate x, you will get s squared over 2. You get s squared over 2. Then minus, if you integrate this s squared, you would have s cubed over 3. And then this is from 0 all the way to 3. That's what you're going to get. The laws of integration. Remember, you add 1 divided by the result you get after adding 1. So 2 we cancel out 2 here. So this will be 2/3 of s squared minus s cubed all over 3 from 0 to 3. Now let's evaluate the limit. So anywhere I see x, I'm going to call it 3. So this will be 3 squared minus 3 cubed all over 3. This is weird. I'll be getting 0 as my answer. Okay, minus. Now put in 0 here. So this will be 0 squared minus 0 cubed all over 3. Now this will be 2/3. Now 3 squared is 9 minus 3 cubed. 3 cubed is 27. 27 over 3 is 9. Minus, this will be 0 minus 0. Now you can conclude that this is 9 minus 9, 0. 0 minus 0, 0. 0 is here, 0 is here. When you minus them, it's still 0. 0 times 2 over 3, still 0. So that one is gone. So a0 is just going to equal to 0. Because every single thing will be 0. Now let's find a sub n. So a sub n is 1 over L, integral from minus L to L, f of s cos n pi x over L dx. So that's our a sub n. So this will become 1 over 3 over 2, integral from 0 to 3. F of x is this. So that's 2x minus s squared cos n pi x over 3 over 2 dx. It's looking like a lot. It's looking like a lot. Okay, let's proceed. Now, if I take the reciprocal of this, the 2 will go up. So this will become 2 over 3. Then integral from 0 to 3. 2x minus s squared cos. Now, if you take the reciprocal here again, this 2 will go up. So this will become 2n pi x all over 3 dx. So that's what you will get. So it's 2 over 3 here, and it will still be 2 over 3 here. So I just kind of, flipped it. So that's what we have. Now next, this will be 2/3, 2 over 3. What I'm going to do next is, if I want to integrate something like this integration by parts, but I don't want to write it out. Instead, I want to do it little by little. I want to do it little by little in a faster way. So I'm going to pick this guy. I'm going to say this is 2x minus s squared. Then I'm going to give some space. When I differentiate 2x, I will get 2. When I differentiate the minus s squared, I will get minus 2x. So I'll keep this, I'll keep this. Then I'll differentiate this again. If I differentiate this again, I'll be getting, the 2 will give me 0. Then when I differentiate minus 2x, I'm going to be getting minus 2. Now this minus 2, if I differentiate again, I'll get 0. But that's useless, so I'm not going to write it. That's useless. Now let's come to this cosine, which is the part you have to be very careful. When you integrate cos, you get sine. So this will give us sine 2n pi x over 3 divided by, when you differentiate the angle with respect to x, what will be remaining is 2n pi over 3. So this will be 2n pi over 3. That's what's going to be remaining. Now this whole thing here that I've just gotten, let me kind of indicate that with red. So every single thing in this red bracket, I'm going to integrate it again for this one. So let's integrate it again. The sine will give us minus cos. So give us minus cos. So this is minus cos. Then the angle is 2n pi x over 3 divided by, now, if you differentiate this angle again, you will have 2n pi over 3. Now that 2n pi over 3 will come and meet this previous 2n pi over 3. So both of them will then form 2n pi over 3 all squared. Okay, so this for this guy. Now again, this would be coming here, so we need to integrate this again for this last part. To integrate this again for this last part, we're going to be having, this is minus, so write your minus first. Integrate cosine, you would have sine, then your angle is 2n pi x over 3 divided by, now this time around, when you differentiate 2n pi x over 3, you will get 2n pi over 3. So it's come and make this 2n pi squared. So now make it 2n pi over 3 all cubed. Okay. So this is what we're going to be having. And the correct sign for this is plus, minus, plus. Then our interval is from 0 to 3. From 0 to 3. Now let me save myself some time. This is sine. And this is my limit that I'll be putting. This is 3. If I should put 3 over 3, that will give me 1. 1 times 2n pi is 2n pi. Sine 2n pi is 0. Yeah, sine n pi is 0. Sine 2n pi is also 0. Sine 0 is also 0. So I just want to save myself the stress. This is gone. This is gone. I'm just going to, this is gone. This is 0. This sign here is also gone. 0. So the only useful one is this one in the middle. So this will be 2/3 into, now let's deal with the sign. This is minus and this is minus. So it's now become plus. So that's 2 minus 2x into cosine of 2n pi x over 3 divided by 2n pi over 3 squared. From 0 to 3. 0 to 3. Man, okay. Let's see what we're going to have. Okay, so the constant term here, this 2n pi over 3 is a constant. So I can bring it out. So this will become 2 over 3 times, okay, 1 over 2n pi over 3 all squared. Now, if you notice, this is 2, this is 2, so 2 is also common here. So I can bring out the 2. Then what will be left here will become 1 minus x cos, 1 minus s cos 2n pi x over 3 from 0 to 3. Take out some time and look at what I've just done so you understand it. There's 2 common here, so I brought out the 2. So this is the 2 here. This one is a constant, so I brought it out. Now if you factorize 2 out here, what will be left is 1 minus x. That's what will be left. And then the numerator. That's what I have. Okay. Now this will be 2 times 2, that's 4, over 3 times, I can expand this. So this will be 4n squared pi squared over 9. When you expand it, 2 squared is 4, n squared is n squared, pi squared is pi squared, 3 squared is 9. And then this will be 1 minus. Let's put in our limit. So this is 1 minus, x is 3. So this is 3 cosine of, now take a look at this. Take a look at this. X is 3. So 3 over 3 is 1. 1 times 2n pi is 2n pi. So this is the upper limit, minus. For the lower limit, x will be 0. So this is 1 minus 0. 1 minus 0. Cos, if we should put 0 here, everything will just turn 0. Everything will just turn 0. Now, this over 9, I can take it to the top. The over 9, I can take it to the top. So this is 4 times 9 over 3 times 4n squared pi squared into 1 minus 3 is minus 2. 1 minus 3 is minus 2. Now, cos 2n pi. Cos 2n pi is equal to 1. Cos 0 is also 1. So, it means that the value of this is 1. So, 1 times the answer I got here will give me minus 2. Minus, cos 0 is also 1. So, I'm just having this answer because 1 times this answer is the answer we get here. So, this is minus 1. That's easy now. So, you just do it. Okay. Now, this will become 4 times 9 over 3 times 4n squared pi squared times, this will give minus 3. So 3 we cancel out 3, 4 we cancel out 4. So what will be left will become minus 9 over n squared pi squared. So this is a sub n. Let me be keeping the answers here. So a naught is equal to 0. A sub n is minus 9 over n squared pi squared. So that's what we have. Now let's move on. Let's look for b sub n. Let's look for b sub n. Let's see what it's going to be. So b sub n is 1 over L, integral from minus L to L, f of s sine n pi x over L dx. Now sometimes, since we've done something like this before, we could be a little bit fast. We could be a little bit, what? Fast, since we've done something like this before. So the only difference between this and this is the sign part. The only difference between this and this is the sign part. So b sub n will become 2 over 3, 2 over 3, integral from 0 to 3. F of x is 2x minus s squared. Then this is cosine, but here we're dealing with b sub n, so this is sine. Now 2n pi x all over 3 dx. Yeah, so that we can just skip some steps. Yeah. Okay, now this is where we then use integration by parts. We're then going to use integration by parts here. So this will be 2/3. Now I'm going to write this value. So this is 2x minus s squared. I'm going to write this value. Give some space. Differentiate this value. You are going to be getting 2 minus 2x. Because when you differentiate 2x, you will get 2. When you differentiate s squared, you will get 2x. And this answer you have gotten here, differentiate it again. You will get minus 2. Because when you differentiate this 2, you will get 0. Then when you differentiate minus 2x, you will get minus 2. Now, should we differentiate the minus 2 again? Yes, but we're going to get 0, so there's no need to do that. Now, this sign here, we're going to be integrating sign. So to integrate sign, let me open up brackets for it everywhere. Okay. So if you integrate sign, you will get minus cos. So this will be minus cos 2n pi x over 3 divided by, when you differentiate this angle, you will get 2n pi over 3. So it will be at the bottom. Then close this up. Now, this whole thing in the red bracket, we are going to integrate this again. So this is minus When you integrate cos, you will get sine. So this is sine. You put your angle 2n pi x over 3 divided by, now when you differentiate this angle, you will get 2n pi over 3. It will come and meet this 2n pi over 3 that has been here before. So make it 2n pi over 3 all squared. So that you get the picture. It's kind of similar to what we've done before. Now, everything in this red bracket, you're going to be integrating it again for this one. So let's integrate this again. So this will become minus, if you integrate sine, you will get minus cosine, then the angle is 2n pi x over 3 divided by 2n pi over 3 cubed. I believe by now you know why that's happening. Because when you differentiate this angle is 2n pi over 3. So it will come and meet this one that has square to make it a cubed. Okay. So this is what we have. And the correct sign for this is plus, minus, plus. And our interval is from 0 to 3. Okay. Now, to make life easy for me, in the previous example, we know that this sign will be giving us 0 over that very interval. So when you put 3 here, 3 over 3 is 1. 1 times 2n pi is 2n pi. Sine 2n pi is 0. Sine 2n pi is 0. So this guy is just gone. Everything in this place, it's gone. Everything here is 0. So I don't want to waste my time. So let me simplify the other side. This will be 2 over 3. 2x minus s squared. This minus, let me put it in front. Minus, then cos 2n pi x over 3. Everything will be divided by 2n pi over 3. Now this part is gone. Now minus, minus, minus. What would that give to us? Minus. I'll be giving us minus. So this is minus 2. Then cos 2n pi x over 3 divided by 2n pi over 3 all cubed. And this is from 0 to 3. All right. This is looking tedious, at the same time kind of beautiful. At the same time kind of beautiful. So what I want to do is, let me put in the limit. Let's put in the limit. You can't, I don't really want to say I want to factorize. So let's put in our limit. So let's put 3 first. So this will be 2 over 3. Then anywhere we see s, let's put 3. So this is minus 2 times 3 is 6. Minus 3 squared is 9. Then cos, when you put 3 here, this 3 we cancel this 3. So what's remaining is 2n pi. All over 2n pi over 3. So keep this one. Minus 2 cos. If you put the 3 we cancel that 3. So this will just be 2n pi over 2n pi over 3 cubed. So this is the upper limit. Minus, now for the lower limit, we're going to be putting 0. But to save ourselves some time, if you put 0 here, 2 times 0 is 0, minus 0 squared. So everything here will be 0. 0 times cosine is 0. 0 divided by this will still be 0. So this part is gone. This part is useless. It's gone. Then minus 2 cos, this expression here will give us 0 over 2n pi over 3 cubed. So this is what we have. Okay. Now, this is a beautiful one. It's a beautiful one. Now remember that cos 2n pi is 1. It's 1. Same thing with cos 0. Cos 0 is still 1. So we can actually save ourselves some time. So this will be 2 over 3 into 6 minus 9 is minus 3. Minus 3 times this minus here will give me 3. So this will be 3 over 2n pi over 3. Now if you notice, cos 2n pi is 1. 1 times anything is that same thing. Then here we'll have minus, this is also 1, right? This is also 1. Cos 2n pi is 1. So 1 times 2 is 2. So this will be 2 over 2n pi over 3 all cubed. That's for this one. Now, minus times minus is plus. Cos 0 is 1. Cos 0 is 1. I really do hope I'm not blocking the view sometimes. Cos 0 is 1. So this will be 1 over, times this 2 here. So then become 2. So this is 2 over 2n pi all over 3 cubed. Close this up. Now, the beautiful thing about this is these two guys will take care of themselves because they're the same thing with different sign. So they'll take care of themselves. So that one is gone. So this is the only thing remaining. So this will be 2 over 3 times 3 over 2n pi. Now this over 3 can come to the top. Yeah, it can come to the top. So it's just going to go there. Now 3 we cancel at 3. Then 2 we cancel at 2. So what will be left to become 3 over n pi. So this is b sub n. 3 over n pi. So that's b sub n. So since we are done with finding all of the coefficients, let's now find the Fourier series of the expression. Let us get the Fourier series. F of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx. Okay, sorry, since this is arbitrary, n pi x over L plus the sum from n equal to 1 to infinity of b sub n cos, this will be sine, n pi x over L. Okay, now already we know this is 0, so let it go first. A naught is 0. A naught is 0, so let it go first. Then this will be f of x equal to the sum from n equal to 1 to infinity. Now what is a sub n? A sub n is this. So this is minus 9 over n squared pi squared cos. Now remember that our L, this n pi x over L, is simplified to be this. So let's save ourselves some time. Because our L is 3 over 2. So when you divide by 3 over 2, the 2 will come up. So I'm just going to be writing 2n pi x over 3. It's just better like that. And then plus the sum from n equal to 1 to infinity. Now b sub n is this. 3 over n pi sine. Then again, this will happen. 2n pi x over 3. Now let's kind of do a little bit of factorization, if it's even called factorization. So this is f of x equal, this minus 9 over pi squared can come outside. So this is minus 9 over pi squared. Then the sum from n equal to 1 to infinity of 1 over n squared cos 2n pi x over 3. Then the 3 over pi here is a constant. So this is plus 3 over pi with the sum from n equal to 1 to infinity of 1 over n sine 2n pi x over 3. Okay, so this is what we have. And this will be the final answer because they said in terms of in the nth term. So you're going to leave your answer like this. Let me take a look at everything. Yep, this will be your final answer to the equation. So with this, we're going to end this very video. I would see you in the next one. Remember to hit the subscribe button, like this video, and share it across to your classmates.